This is the Algebra Regents exam, June 2018, multiple choice. In question number one, the solution to this equation. So anytime that you have parentheses, you want to get rid of the parentheses first. So you had to distribute and distribute first. So you have 2 times p and 2 times 5. So that turns into 2p plus 10. You want to get all the p's on the one side. So minus 2p and minus 2p. Those 2 p's cancel out. 4p minus 2p is 2p. Then you just have a 2-step equation. Subtract by 2's, divide by 2's. You end up with p is less than 4, which is choice 4. Please remember that in this step right here, all right, if that was dividing by -2, you would have to flip the sign. If that was a -2, you'd have to flip the sign. So be very careful with that. In question number 2, if the k of x equals that, then they want to know what the k of 9 is. There's 2 different ways to do it. All that you have to do really is sub in a 9 and sub in a 9 where the x's are. So you could type 2 times 9 squared minus 3 radical 9. When you do that on the calculator and hit equals, you get 153. Or you could always treat this as a y equals and graph it, and then do second and table and take a look at what the value for x equals 9 is. Either way, you're going to get 153. In question number 3, be very, very careful on this one, all right? What you want to distribute with is actually a -4, all right? Because the minus sign here, you want to distribute with a -4, and therefore you're going to make it into an adding question right away. You could distribute with just a +4. You could do it that way also and be a subtracting question, but then you're going to have to change all the signs in that bottom row. So if you go and do that, you end up, I would do it distributing with the -4. I think that's easier because it makes it right into an adding question. So you line up the x squareds underneath the x squareds, the x's underneath the x's, the plain numbers with the plain numbers. Treat your minus signs as negative signs. So you end up with choice 2, which is -13x squared plus 34x minus 29. In question number 4, the zeros. The zeros are your x-intercepts. So again, all that you have to do is graph it. Where it says p of x, that's just really your y equals. So type that right into your y equals, hit graph, and take a look at your zeros on your graph. The zeros are the x-intercepts. So that is -4 and +6. In question number 5, the box and whisker plot, the third quartile. Please remember that this number is your min. This is the first quartile. This number is your median. This number is the third quartile. And then this number is your max. So the number at the third quartile, you go straight down from the edge of the box here. And when you go straight down from the edge of the box, you get 90, which is choice 2. In question number 6, Joy wants to buy strawberries and raspberries. Strawberries cost $1.60 a pound, raspberries $1.75 a pound. If she only has $10 to spend, that is the most that she can spend. Can she spend equal to $10? Yes. Can she spend less than $10? Yes. Can she spend more than $10? No. So right away, it's not choice 2 and it's not choice 4 because those say greater than. At most is less than or equal to. So it has to be choices 1 or 3. The difference between 1 and 3 is the number in front of the x, the number in front of the y. It says specifically that x is the pounds of strawberries and y is raspberries. Strawberries are $1.60, raspberries are $1.75. So it has to be $1.60 times x plus $1.75 times y, which is choice 1. In question number 7, the really only way that I would even do this is to actually write out the pattern like I did. It says on the main floor, the number of seats per row increases at a constant rate. Increases at a constant rate means that you're adding the same number each time. Stephen counts 31 seats in row 3 and 37 seats in row 6. How many seats are there in row 20? Well, if in row 3, there's 31 seats and row 6, there's 37, I need to figure out how I got from row 3 to row 6. Well, just by trial and error, if you go and start adding by 2 each time, in row 4, it would be 33. In row 5, it would be 37. We add another 2 for row 6. That gets, or 35, that gets you to row 6, which is 37. So what we're doing is we're adding by 2 each time. That increases at a constant rate. Then just continue on with the pattern. It takes a little bit to do it out like this, but it is a way to do it. So each time we're adding 2 to the row. So eventually when you get to row 20, there are 65 seats in the row. You could do it like this, but I think that's way harder. All right, I would just write it out like this. This is your, this is 27 is in row 1. All right, 29 would be in row 2, and you can figure it out like that. That's way harder to do though. Which ordered pair is not a solution? Again, anytime that it says whatever letter of X, that's just your Y equals. So type it into your Y equals and see which one is not a solution. You could just do second and table and look at your X value. So your X value is -1, your X value is 5, your X value is 0, your X value is 1.5. Remember, you could change the settings on it. And when you do that, you're looking at your Y value. This one is not a solution. In question number 9, what percentage of the students chose soccer as their favorite sport? Well, in order to do that, you need to figure out how many total people were surveyed. So you have to add up your basketball, add up your soccer going down, add up your tennis going down, add up the number of girls, add up the number of boys. You eventually end up with 250 total people being surveyed. What percentage of those chose soccer as their favorite sport? There were 99 total people that chose soccer out of 250. Top divided by bottom, 99 divided by 250, you get this decimal. To make a decimal into a percent, you move the decimal point over 2 places to the right, and you get 39.6. In question number 10, the trinomial x squared minus 14x plus 49 can be expressed as which one? So you could do reverse FOIL to this. What times what is 49? That adds up to -14. Or you could just do FOIL to all 4 choices and see which one matches the original problem. Either way, you're going to get the same answer. It's x minus 7 times x minus 7, or x minus 7 squared, which is choice 1. In question number 11, a function is defined as those 4 points. Isaac is asked to create one more ordered pair for the function. Which ordered pair can he add to the set to keep it as a function? So what makes it a no is that if there's 2 x values that are the same, that's when it's not a function. That's when you're going to end up with 2 dots that are directly above each other. Remember that when there is 2 dots that are directly above each other, that's when it's a no. So adding another point with a 0 as our x value, that matches this one. We can't have that. We can't have this one with the 5. We can't have this one with the 7. But this one is its own unique y or x value. So that one would be fine. So it would be choice number 4. That would still be a yes as a function. In question number 12, the quadratic equation, this one, x squared minus 6x equals 12, is rewritten in the form like this, where q is a constant. So q is a number. What is the value of p? Well, what you have to do in this one, and this one's a little bit harder, is you have to complete the square, all right? Because by completing the square, you're going to take it from something that looks like this to something that looks like this halfway through the process. So when you go to complete the square, you have to take half of your b value and square it. So half of -6 is -3. -3 squared is -3 times -3, which is +9. That's the number that you have to add to each side. So now we have the trinomial x squared minus 6x plus 9 equals 21 when we add together 12 plus 9. This can be simplified. This trinomial, if we do reverse FOIL, what times what is 9? That adds up to -6. Well, it would be -3 times -3. So that's going to be x minus 3 squared equals 21. That would be our next step. And that matches, all right, this matches this right here. So our p value, because they want to know what is the value of p, where inside those parentheses, it's a -3. So that would be choice 3. That one's a little bit more difficult. Which of the following quadratic functions below has the smallest minimum? So that's your lowest point in your parabola. So you should just graph it. When you graph this one, you get that this low point right here on the bottom part of the parabola is -7. On this one, when you go to graph it, the lowest point on the parabola is -2.25. The lowest point on the parabola in this one is -10. And according to these points, the lowest one would be the lowest point for our y value, because f of x just means y. The lowest point here is -6. So out of -7, -2.25, -10, and -6, the smallest number is -10, which is choice 2. In question number 14, which situation is not a linear function? What makes something linear is adding or subtracting the same number each time. So a gym membership charges a membership fee of $10 down and $10 per month. You're adding 10 every month, so that's going to be very linear. Taxi cab company charges $3 per mile. Every mile that you go, you're adding $3, so you're adding the same amount each time. A restaurant employee earns $12.50 per hour. Every hour that that person works, you're adding $12.50. In question number 4, anytime that there's a percentage, that percentage is going to make it not linear, all right? Because the car is depreciating or going down by 15% each time. So you're actually going to get an exponential curve that goes down, 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 all right? Down like that. Because you're taking 15% of the value each time, 15% of different numbers is going to be different numbers. In question number 15, so this one's a little bit more complicated as well. You have to refer back to your reference sheet. On your reference sheet, it does tell you that 1 mile equals 1.609 kilometers. So it says that this race is a 12-kilometer race, which run are at least 15 kilometers. So we want to convert all 3 of these measurements individually into kilometers. To make miles into kilometers, we would have to multiply by 1.609. So 10 times 1.609 gives you 1609. Is that one at least 15? Yes, it is. All right, because it's greater than or equal to. You have to be at least 16 years old to drive a car. You can be equal to 16 or older than 16. So this one is correct. How about 44,880 feet? Well, you don't have in your reference sheet, you don't have a conversion that goes from feet to kilometers. So therefore, we need to change this feet into miles first. When we change the feet into miles, you have to divide by 5,280 first, and you get that it is 8.5 miles. Now we can convert it to kilometers by multiplying by 1.609. We get 13.67. Is that at least 15? No, it's not. All right, that's less than 15. Then we have 15,560 yards. We don't have a conversion in the reference table that goes from yards to kilometers. So we need to change the yards into miles first. One yard is 1 mile is 1,760 yards. So we have to divide that by 1,760 to get 8.8 miles. Multiply that by 1.609 to make it into kilometers. You get 14.22. That is not at least 15. So the only one is number 1, which is choice number 1. In question number 16, what is the range of this function? Well, all you would have to do is graph it. When you graph it, it looks like this. Remember that range means your y values. Remember that domain are your X values. This one's asking about the Y values, which are your range. So all of our Y values on our Y axis, all of them are up above 2. 2 is our lowest number here. It includes the 2 when you take a look at the graph. So that's why it is the squarey kind of parentheses, those brackets, and then all the way up because these keep on going up, 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 up. So it is from 2 to infinity, which is choice 3. In question number 17, the amount Mike gets paid weekly can be represented by the expression 250A plus 290, where A is the number of accessories that he sells each week. What is a constant term? Constant means just a plain number in this expression. And what does that represent? So the constant term is this 290. They want to know what that 290 represents. That 290 is the amount of money that he's guaranteed each week. So no matter how many accessories he sells, he earns $290. Plus, he earns sort of like a bonus. He's working on commission, right? For every two, he earns $2.50 for every accessory that he sells. In question number 18, all you have to do is graph these, all right? Take each one individually and type it into your Y equals and see which graph matches the graph. So that would be question or answer number 2. That one's going to match it. In question number 19, which student's response is correct? Mrs. Aller asked her students to identify which of the polynomials are in standard form and explain why. Standard form. Standard form means that the exponents are in order. It makes no difference at all what number is in front of the X. We have to put the exponents in order, like 7, 5, 3, 1, or 6, 5, 4, 3, 2, 1. You have to take a look at your exponents. 1 is not correct because this would have an exponent of 1. This has an exponent of 2. So these are in the wrong spots. Our plain one without the exponent comes last all the time. This one is in order. We have 3, then 1, then nothing. This one is in order, 5, 2, 1. So the 2 that are correct are choices 2 and 3, which is choice 3, because the exponents are decreasing as you go from left to right. In question number 20, which graph does not represent the function, right? Represent a function that is always increasing, so always going up over the entire interval from -2 to +2. Do I care anything about the numbers that are less than 2? No. So I'm not looking at this part of the graph. I'm not looking at this part of the graph. Not looking at this part of the graph. Not looking at this part of the graph. Do I care anything about the numbers that are bigger than 2? Nope. All that I'm looking at are the numbers or the graph in between those 2 lines. So which graph does not represent something that's always increasing? Is choice 1 increasing? Yes, it is. Is choice 2 increasing in between the 2 red lines? Yes, it is. Is choice 4 increasing between the 2 red lines? Yes, it is. Notice that choice 3, which is our correct answer, notice that that goes up, but then it goes down. So that would be choice 3. At an ice cream shop, the profit is modeled by this equation, where C is the number of ice cream cones sold. What would be an appropriate domain for this function? Can you go to an ice cream store and ask for, oh, I'll take 2/3 of an ice cream cone? No, they're not going to sell you 2/3 of an ice cream cone. All right. So we can't have partial numbers. You also can't sell negative numbers of ice cream cones. That doesn't make any sense. So we can't have choice number 1 because we can't have a negative number. That would be an integer that is less than 0. We can't sell negative numbers of ice cream cones. We also can't have 3 or 4 because 3 or 4, a rational number could be a number like 2/3. It could be a number like 0.5. You're not going to sell somebody half of an ice cream cone. All right. So you can't have partial cones like that. So it can't be 3 or 4. It has to be an integer that is bigger than 0, like 1, 2, 3, 4, 5, 6, 7, 8, etc. In question number 22, how many real solutions does that have? All that you have to do is graph it. All right. Notice that it's already set equal to 0. If it wasn't set equal to 0, we would need it set equal to 0. Then you can just type it into your y equals. So when we type it into the y equals, you get this graph. Notice that this graph does not cross or touch the x-axis at all. Because it doesn't touch or cross that, it doesn't have any zeros. So how many answers or solutions or roots or zeros does it have? It doesn't have any, which is choice 3. In question number 23, this one's sort of a pain in the butt. What I noticed first is, first of all, we have to rearrange this formula. P equals 2L plus 2W. What I noticed right away is that number 1 and number 2 are actually the same exact formula. If I took number 2 and I distributed and distributed, 1/2 times P is 1/2 P. 1/2 times 2 is just 1, which is the same as this one. So choice 1 and 2 are actually the same exact thing. Choice 3 is a little bit different. So when you go to rearrange them, we want to rearrange them for L equals. Notice that that's how all of these are rearranged, as L equals. So we want to try and get this L all by itself. One way to get the L all by itself is to do minus 2W and minus 2W. P minus 2W is just P minus 2W. Bring down your 2L. This is 2 times L. The opposite of times is divide. So divide by 2, divide by 2. And we end up with this answer. Notice that that answer is the same exact thing as number 3. Another completely different way to rearrange it, because we have a 2 in front of the L and a 2 in front of the W, is to divide all of these by 2. If we divide each term by 2, P divided by 2 is really just 1/2 P. All right, that's just a different way to write it. Those 2's cancel out. Those 2's cancel out. So you just have L plus W. To get the L all by itself, minus W, those cancel out. So we end up with 1/2 P minus W, which is what we have here, which is what we have here. All 3 choices work, so it would be choice 4. And in question number 24, our sequence question, they tell you that the A sub 1 is 1. So that's what we're starting off with. The A sub 1 is 1. They want to know what the A sub 5 is. So they want you to sub it into here. N is the value of the term. So N, we would be subbing in for A sub 2, we're subbing in a 2 in that spot. For A sub 3, we're subbing in a 3 in that spot for the N. All right. For A sub 4, we're subbing in a 4. A sub 5, we're subbing in a 5. Then they want you to take the previous term. That's what this means right here. A sub N minus 1 is your previous term, and sub it in. So when we go to find the A sub 2, you're taking 2 times your previous answer, which is 1. 2 times 1 is 2. A sub 3 is our N. We're taking our previous term of the 2 and subbing it in. 3 times 2 is 6. Taking this 6, subbing it into there. A sub 4 is 4 here for the N. 4 times 6 is 24. Taking that 24 and subbing it in, 5 times 24, you end up with 120. On this particular exam, what ended up being a passing score was only 13 multiple choice questions correct. Remember, each multiple choice question is actually worth 2 credits. And so that is the passing score on this one.